Portable generators may or may not have a system bonding jumper installed. It depends on the specific generator model and the manufacturer. Smaller portable generators with receptacles mounted on the frame typically have a system bonding jumper that is neutral to ground. This is because these generators are often used in residential or commercial applications where it is required to bond the neutral and grounding conductor together to ensure proper grounding and safety. Larger trailer generators may or may not have a system bonding jumper. Some trailer generators are designed for use with appliances and equipment that do not require a bonded neutral, such as construction tools or temporary lighting. In these cases, a system bonding jumper may not be necessary. However, some trailer generators may have a system bonding jumper installed if they are intended for use in applications where a bonded neutral is required, such as residential or commercial buildings. It is important to refer to the specific manufacturer's specifications for the generator to determine if it has a system bonding jumper and how it should be connected. The National Electrical Code, or NEC, requires that the neutral conductor of a generator be bonded to the frame of the generator and the grounding electrode system of the building or structure where the generator is used. The system bonding jumper is typically located inside the generator control panel and may be labeled as neutral bonding jumper or grounding jumper. If you are unsure whether the portable generator has a system bonding jumper, it is best to consult with a qualified electrician. To elaborate on the specifics of system bonding jumpers in portable generators, we can delve into the reasons behind their presence or absence and the implications for safe operation. Firstly, consider the smaller portable generators commonly used for powering tools, appliances, or lights during a power outage or at remote locations. These generators, often with receptacles directly mounted on their frames, typically incorporate a system bonding jumper connecting the neutral conductor to the generator's frame, which is also connected to ground. The primary reason for this design is to establish a solid grounding reference, enhancing electrical safety. In a properly grounded system, any fault current, such as a short circuit from a live conductor to a grounded part of the equipment, will have a low impedance path back to the generator. This low impedance path facilitates the quick tripping of a circuit breaker or fuse, interrupting the flow of current and minimizing the risk of electrical shock or fire. Without this bonding jumper, the fault current might not be high enough to trip the overcurrent protection device, leaving the equipment and users vulnerable. Secondly, let's examine the larger trailer-mounted generators. These units often present a more complex scenario. Their application range is broader, spanning from powering construction sites to serving as backup power for commercial establishments. Unlike their smaller counterparts, these generators may or may not include a system bonding jumper. The decision to include a bonding jumper hinges on the intended use and the electrical system is designed to supply. In some instances, these generators are intended to supply power to equipment that doesn't require a bonded neutral. For example, certain construction tools or temporary lighting setups may operate safely without a direct neutral to ground connection at the generator. In these cases, the absence of a bonding jumper simplifies the setup and avoids potential conflicts with existing grounding systems. However, if a larger trailer generator is intended to supply power to a structure with a grounded electrical system, such as a residential or commercial building, a system bonding jumper is crucial. Connecting the generator's neutral to ground ensures that the building's grounding system and the generator's grounding system are properly tied together, providing a safe path for fault currents and enabling the overcurrent protection devices to function correctly. It's essential to remember that the National Electrical Code, or NEC, provides comprehensive guidelines on generator installations, including bonding and grounding requirements. The NEC mandates that the neutral conductor of a generator must be bonded to the generator's frame and connected to the grounding electrode system of the building or structure it serves. This requirement is in place to maintain electrical safety and prevent potential hazards. The system bonding jumper, typically located within the generator's control panel, may be labeled as neutral bonding jumper or grounding jumper. However, its presence and configuration should always be verified before connecting the generator to any electrical system. When in doubt, consulting a qualified electrician is always the best course of action. Electricians possess the expertise and knowledge to assess the specific application, determine the appropriate bonding and grounding requirements, and ensure that the generator is installed and operated safely. Furthermore, it is crucial to consult the manufacturer's specifications for the specific generator model in use. Generator manufacturers provide detailed information on the generator's electrical characteristics, including the presence or absence of a system bonding jumper, recommended wiring practices, and safety precautions. Adhering to the manufacturer's recommendations is essential for safe and reliable operation. In addition to understanding the role of system bonding jumpers, it's important to be aware of the potential hazards associated with improper generator grounding. A floating neutral, which occurs when the neutral conductor is not properly bonded to ground, can create dangerous voltage fluctuations and increase the risk of electrical shock. Similarly, improper grounding can lead to equipment damage, fire hazards, and even electrocution. Therefore, it's imperative to take generator grounding seriously and follow all applicable codes and safety guidelines. Here are some additional considerations regarding portable generator bonding and grounding. Firstly, isolated power systems. In some specialized applications, such as powering sensitive electronic equipment, an isolated power system may be used. In an isolated power system, the neutral conductor is not bonded to ground at the generator. This design is intended to minimize electrical noise and prevent ground loops, which can interfere with the operation of sensitive equipment. However, isolated power systems require careful design and implementation to ensure safety. Secondly, transfer switches. When connecting a portable generator to a building's electrical system, a transfer switch is essential. A transfer switch isolates the building's electrical system from the utility grid, preventing backfeed and ensuring that power flows only from the generator to the building. Transfer switches also provide a safe and convenient way to switch between utility power and generator power. Thirdly, grounding electrodes. The NEC requires that portable generators used to supply power to a building be connected to a grounding electrode system. A grounding electrode is a conductive rod, plate, or wire that is buried in the earth and connected to the generator's frame. The grounding electrode provides a path for fault currents to flow to ground, helping to protect against electrical shock. Fourthly, GFCI protection. Ground fault circuit interrupter, or GFCI, protection is highly recommended for all receptacles powered by a portable generator. GFCI devices detect small imbalances in current flow and quickly interrupt the circuit, preventing electrical shock. GFCI protection is especially important in damp or wet environments, where the risk of electrical shock is higher. Fifthly, regular inspections. Portable generators should be inspected regularly for signs of damage or wear. Check the cords, plugs for receptacles, and frame for cracks, breaks, or corrosion. Ensure that all connections are tight and secure. If any problems are found, have the generator repaired by a qualified technician before using it. Sixthly, carbon monoxide safety. Portable generators produce carbon monoxide, a deadly, odorless gas. Never operate a portable generator indoors or in an enclosed space. Always operate the generator outdoors in a well-ventilated area, away from doors, windows, and vents. Install carbon monoxide detectors in your home and check them regularly to ensure they are working properly. Seventhly, fuel handling. Gasoline is a flammable liquid and should be handled with care. Store gasoline in approved containers away from heat, sparks, and open flames. When refueling the generator, allow it to cool down completely before adding fuel. Avoid spilling fuel and wipe up any spills immediately. Eighthly, overload protection. Do not overload the generator. Check the wattage rating of the generator and do not exceed it. Overloading the generator can damage the generator and create a fire hazard. Ninthly, proper storage. When not in use, store the generator in a dry, well-ventilated place. Drain the fuel tank before storing the generator for extended periods. Cover the generator to protect it from dust and moisture. Tenthly, professional assistance. If you are unsure about any aspect of portable generator bonding, grounding, or operation, consult with a qualified electrician. Electricians have the training and experience to ensure that your generator is installed and operated safely. Understanding the nuances of system bonding jumpers in portable generators is crucial for ensuring electrical safety and preventing potential hazards. By considering the specific application, consulting the manufacturer's specifications, and following all applicable codes and safety guidelines, it is possible to use portable generators safely and effectively.